Okay, we're going to work through the first four problems of the final from spring 2012. These were all one point problems, so they were intended to be very short. The first one, I asked how many gallons in a cubic yard. Okay, so this is a conversion problem. Any sort of conversion that's not a very standard one we will give you. So in this case we do give you this conversion. 1 foot cubed is equivalent to 7.48 gallons. But to work this problem we're starting off with a cubic yard. So 1 yard cubed. We do expect you to know that 1 yard is equivalent to 3 feet. We want to get to feet because that's in this conversion, and to recognize that you're going to have to cube that yard, this conversion, to cancel out the cubic yards here. Okay, and then to go from feet to gallons, we got feet cubed is 7.48 gallon. Gallon is a unit of volume. Okay, so if we put that into our calculator, we would have, do it again here, 3 cubed times 7.48. 201.96, or 202 gallons. Okay. The second one, friction force between an object if the object is not moving. So here's the key to this one. It's not moving. We don't know if it's impending motion or not, so we cannot use the maximum friction force as the static coefficient of friction times the normal force. So the friction force is just given from the free body diagram. So a real quick free body diagram. Weight, normal force, pushing force of 10 pounds, and a friction force in the opposite direction. Okay, if we look at forces in the positive x, we would have 10 minus F equals 0, or F is simply 10 pounds. Okay. You don't use this information because we know it's not sliding, and we don't know if it's impending motion or not. To see if it were sliding, you would take the normal force, which in this case is the same as the weight. So that's 20 pounds times the coefficient of static friction, 0.8. So the maximum friction force would be 20 times 0.8, or 16 pounds before it would start sliding. That's the wrong answer. Okay, number 3. How much hydropower must be input to the generator if it's 40% efficient to power a 13-watt bulb? We gave the equation as general terms of useful over total. Okay, so in this case our efficiency is 40%. The useful is what we're doing, 13 watts, and so the total power would be calculated here. So total power looks like 13 divided by 0.4, or 32.5. Okay. Think of it in these terms, and it's a little bit easier to keep track of whether you multiply or divide by the efficiency. On our last problem here, we're simply asked to locate the approximate center of mass of this shaded object. We know that this horizontal line is a line of symmetry, so it's going to be somewhere along that line. Okay, if it were a full circle, it would be right at the center, but we have actually taken some mass out on this side, so the center mass will actually shift off to the left. If we knew the radiuses of these two objects and it was standard uniform thickness and density, we could calculate that location, but just from the arrangement we know it's somewhere to the left. Okay, so we'll finish up the first four problems there.